In this lesson, we're looking at the addition of vectors. So it says we can add two or more vectors together to determine a single vector called the resultant. This is the result of applying one vector followed by another, which is what we saw yesterday when we looked at the perpendicular components of a resultant vector. So let's start off by looking at parallel vectors. So if two vectors are parallel in the same direction, then the resultant is also in the same direction. So for example, if I have vector u, we'll call this one, and vector v, we'll call this one, and these are parallel vectors. Then, of course, when I add those together, so if I apply vector u first, followed by vector v, then the resultant vector will be in the same direction as the two component vectors. So this would be vector u plus v over here. If two vectors are parallel but going in opposite directions, then the resultant will have the same direction as the larger vector, longer vector, I guess I should say. So if we have then vector u, and then we're going to apply vector v, and maybe it goes this opposite direction, then if we apply vector u, then from where we left off, we apply vector v. So I forgot to label that one. Then the resultant would be the vector that runs from where we started, so here, to where we ended up. So that's what we mean by it will be in the same direction as the longer vector, which in this case was vector v. Okay. When adding two opposite vectors, it is possible to get the zero vector, which has a magnitude of 0 and has no specific direction. So let's think about that. If we had vector u, and then we add to that an equal but opposite vector v, then our resultant vector would really just be nothing at all. Okay, so if we look at from where we started at to where we ended up, we would be in exactly the same spot. So that's what we mean by the zero vector. So it has a magnitude of 0. Now, there are two methods we can use for adding two vectors together. So if we have two vectors which are positioned head to tail, such as these two, we have vector u followed by vector v. So this is what we mean by two vectors that are placed head to tail. Then the resultant vector is the vector that joins the tail of one to the head of the other. So this would be vector u plus v, and hence why we call that the triangle law. The parallelogram law is used when adding vectors together that are placed tail to tail. So let's look at one like that. So that would be, let's say we have vector u and vector v. Now if I want to add those together, what I do is I sort of slide vector v over to this side, so that we can then add these two vectors together, basically using the same sort of triangle law that we used before. But we call it the parallelogram law because, of course, if we slide these two vectors to the opposite sides, what we've created is a parallelogram. Okay, so the green vector in the middle is our resultant vector u plus v. Okay, so triangle law and parallelogram law for adding vectors. All right, this example says determine the magnitude and direction of u plus v if u has a magnitude of 5 units and v has a magnitude of 8 units, and the angle between them is 30 degrees when they are placed head to tail and tail to tail. So you might need to write sort of small. I realized after I should have left you a little more space here. Now, if they are placed tail to tail, or sorry, head to tail for the first one, then we could draw that kind of like this. So we could have vector u, assuming the pen wants to cooperate. I'm going to try that again. Okay, that's better. We could have vector u, and which has a magnitude of 5, followed by vector v, which has a magnitude of 8, and the angle between them is 30 degrees. Now we need to find the resultant vector, the magnitude and direction, that is, of the resultant vector, which would be over on this side. We'll label that with an R. So we'll say, let R be the resultant vector of u plus v. So we're trying to find the magnitude and direction of the resultant R. Now what we can do here is use the cosine law. Because I have the measures of two sides, here and here, and the measure of the angle contained between them. So that's where we could use the cosine law to find the length of side of the resultant side. So we would say the magnitude of r squared is equal to 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of 30 degrees. Okay, when you type that all into your calculator, you get 19.72, of which you will take the square root, and that gives you 4.4. So the magnitude is 4.4 units, and now we also want to find the direction. So we could find the direction by finding the angle of that resultant vector relative to vector u, for example. So we're going to find that angle theta. That's supposed to be a theta that I drew in your picture. It doesn't really look like a theta. See if I can fix it. Right here. Okay, so I could, for example, use the sine law then. So as our second step, I could use the sine law to find that angle. So I know that sine theta over 8 is equal to sine 30 over 4.4, which we just found. And then you can use your calculator to determine that theta is approximately 65 degrees. So then we would say, therefore, the magnitude of the resultant vector is 4.4 units. And the direction is 65 degrees relative to vector u. Now, if u and v had been placed tail to tail, then we would need to use the parallelogram law. So that would be if we had vector u, which has a magnitude of 5, here, and then tail to tail from that we have vector v, which has a magnitude of 8. So now in order to find the magnitude of that resultant, this is where we would need to slide vector v over here to the end. Okay, and this would be vector u. And then our resultant will be up through the middle of this parallelogram. Okay, so once again, we're going to use cosine law to find the magnitude of that resultant. Oh, I guess we have a little bit of extra work to do here, though. So we know that the angle between u and v is 30. So therefore we know in a parallelogram these interior angles add up to 180. Those are supplementary angles. So that will help us find the measure of this angle here, which would be 180 minus 30, so 150 degrees. Okay, so then again we're going to use the cosine law, and we're going to say the magnitude of r squared is equal to 8 squared plus 5 squared minus 2 times 5 times 8 times the cosine of 150 degrees. So r squared equals 158.282, and then when we take the square root of that, we get an r, the magnitude of r, which is 12.58. Okay. Then, once again, we want to find the direction of that angle. So if we want to find, of that resultant vector, sorry. So if we want to find the direction relative to, say, vector u once again, my picture is getting a little bit complicated, but we want to find this angle here. So we're looking at this triangle, just to make this a little bit clearer, hopefully. Okay, and we're going to call this angle theta. So now, once again, I can use the sine law to find the measure of that angle. So we can say, for example, sine theta over 8, which is the length of vector v, is equal to sine 150 over the magnitude of the resultant, which is 12.58. And then once we solve that, we can figure out that angle theta is approximately 18.5 degrees. So we'll say, therefore, the magnitude is 12.58 units, and the direction is 18.5 degrees to vector u. Okay, it's a bit difficult to fit that into that space, so if any of that is not clear, just let me know. All right, our last example is an airplane example, and I'm just a little concerned about running out of time with this question, so I think I'm going to have you refer to the second part of this video to fit that in.